Hello guys, so what we're going to deal with today is data types and declaration. Last session we did some explanation on the preprocessors and the directives, and also we dealt with the most common one, which is has include and has define, and also has if and have if and if. Those were the different things we dealt with last session about directives and preprocessors. So here in this case today we're going to deal with declaration. But before explaining about declaration, we should understand about how the data types work and the kind of data the computer can process. When it comes to computers, they can only understand zeros and ones. Those zeros and ones, they can be either character data types, or you can say that numbers. So numbers can be categorized into different parts. We have what you call integer data types and floating point data types. We have real numbers and also we have whole numbers. There are certain data they can only be whole numbers. They cannot be in decimal form. They cannot be fractional part. That's what you call integers in mathematics, or data that can only be discrete in computer science. If I want to ask you to count the number of students we have in a particular class, those number of students, you cannot count them as fraction. You cannot say we have 2.5 or 10.5 students in the class. Who is the half? So people, you cannot count them as, you cannot be in a decimal format. They cannot be in fraction, right? No matter how sad the individual is, cannot be a fraction. The same thing. So those data, they can only be integer data types, right? But when you talk about bag of sugar, we can have half bag of sugar, whatever. Those one can be in the form of fractional data types, which is what floating point or real number, floating point numbers. But when it comes to these integer data types, even though they are only pure whole numbers like 1, 2, 3, 4, or you can call them discrete numbers in computer science, those discrete numbers, they still categorize them into different sections, which is sort data type and int. But if I use sort to represent data types, I'm dealing with a very small space, knowing that the kind of data I'm dealing with is very small, or might be these kind of spaces enough to hold it. Like if I want to record the age of people in a particular database, we know the age of people cannot go up to 1,000. You cannot say that someone have 1,000 years. The range of that age is at least from, let's say, 1 to 100 or 1 to 120 or 1 to 150. Very rare. So those kind of data is not necessary for you to cut a big space to store that data. It's a waste of resources. Integer data type can take a bigger space for that, right? Maybe in some cases, in typical compilers, sort is 2 bytes, meaning 16 bits, while int is 4 bytes, which is 32 bits, right? Meaning it normally gives a big space. If I'm recording a big numbers, like the population of a country, all right, or maybe I'm dealing with, let's say, data that are far beyond millions, or, you understand, far beyond millions. So those data, I can represent them in int or long. Even we also have another one which is long int, right? But those one, anyway, we will talk about it, meaning what long int normally give us a long data type, right? So this what we have. When we are dealing with that, I can represent those big data as int. The same thing happens, so they are dealing with fractional data types. Those fractional data types, again, the same thing. Here what we have, it can represent, float can represent a short space. But the difference between float and int, float, it also record fractional part, which is, let's say, 2.55. But when it comes to int, it can only record 2, 3, 4, no decimal part. So if I want to involve a data type which represent, right, 2.545 or 2.6 or 2.7, as far as it involves point value, point data, or floating point data or fractions, I have to choose this kind of data type. But again, the kind of data I'm dealing with, again, it will justify whether I will use float or I will use double. All right, so that's what it means. So both double and float, they represent only data that deal with floating point number. When it comes to character, it's dealing with everything on our keyboard. Either you are dealing with 1, 2, 3, 4, 5, 6, A, B, C, up to Z, or both the capital and the lowercase and the special characters, which is like has, you can say that ampersand, or you can maybe you are dealing with dollar sign, all those special characters, even space. This car data type will define them in the computer. Like we'll tell the computer the kind of data you're expecting is a character data type, right? So that character data type, now the computer will understand exactly that this data I'm expecting is in the character form. So I have to cut a space that is correspond to a character data type, meaning when the character come, it will fit in the space. I will not waste resources there, and also the data will be stored in those memory cells. Then we come to variables. Variables, again, the same thing. Since computers, they are arranged in cells, and each cell have an address. Those addresses, they are in hexadecimal numbers, or you can say that they are in ones and zeros. If those cell numbers, when it comes to the memory, it's just like a street. It's just like a village. Each compound have its own, or you can say it's just like a city. Each compound have its own address. The memory cell, again, the same thing. Each space have an address. Those addresses, they are in machine code, which is either zeros and one or hexadecimal, as what we normally see in assembly language. So those hexadecimal numbers, you cannot remember them always. You cannot. So what the compiler do is allowing us to use our own natural language and what, and be specify those, like link it with those hexadecimal or those machine level codes or those zeros and one. We cannot remember zeros and one. Computers also don't know our natural language, but the compiler is in between to translate between the hexadecimal part and the variable, right? So here in this case, I can, if I want to like specify a number or store a number, I can just say int number. I declare it now. This number right now, it represents a particular address in the computer cells. Now, anytime I want to store maybe a number, any number, if I want to store it, if I specify, if I assign it with this number, that number will, that value will be stored in the memory address called number, right? Even though it linked with a particular address, only the compiler and the computer knows those numbers. But for my level as a human being, I know that the address name is number. All right. So here, if I say number equals 10, then here in this case, this 10 will be picked and put in what, in the number category. Don't worry, we will come to assigning and declaration. But here in this video, I just want you to understand how data are categorized in computers. There are more than this, but in our other videos, we will talk about those things. See you later.